This lesson, we're going to generate the quotient rule. Unlike the other differentiation rules that can be derived from the first principles, quotient rule can be derived directly from the product rule. So let's take a look. Given fx equals to ux over vx, we can write it as f equals to u over v. And then we're going to change it into a product. So we are going to multiply by v on both sides. So fv equals to u. And use the definition of the product rule, then we can have f prime v plus fv prime equals to u prime. Next, we are trying to isolate for f prime. That means we have to remove fv prime. That means we have to subtract fv prime on both sides. So f prime v equals to u prime minus fv prime. And at the same time, we know f is u over v, so we're going to replace f with u over v. So f prime v equals to u prime minus u over v times by v prime. And that's putting into one single fraction by using common denominator. So we're going to have f prime v equals to u prime over 1 minus u v prime over v. And by finding a common denominator, the first fraction has to times by a v in both numerator and denominator. And that's put into one fraction now. So it becomes u prime v minus u v prime over v. Next, we have to isolate for f prime. That means we have to divide v on both sides. So we're going to have f prime equals to u prime v minus u v prime over v. And divided by v really means times by 1 over v. So then we are going to have f prime equals to u prime v minus u v prime over v squared. Therefore, we say, given the function fx is a quotient u over v, then your differentiation will be u prime v minus u v prime over v squared. That's the quotient rule. Now, let's look at example 1. We want to find the derivative of a f, and f is a fraction. However, there is only one term in the denominator. That means I could use power rule to differentiate this. So first, we're going to divide them into 3 different terms. So 4x squared over 2x plus 5x over 2x plus 8 over 2x. And then we are going to change them into exponential form. So 2x plus 5 over 2 plus 4 over x, which means 2x plus 5 over 2 plus 4x to the exponent negative 1. And once we have all the individual terms, and there's no fraction, there's no radicals, we are ready to use the power rule. So f prime x will be 2 plus 5 over 2 is a constant, becomes a 0, and 4, bring down the exponent 1, x to the exponent negative 1 minus 1. So you're going to have 2 plus negative 4, x to the power negative 2. And because there's a negative exponent, we're going to change them into a fraction to avoid the negative exponents. So we have 2 minus 4 over x squared. Next, we're going to use quotient rule to differentiate the function f. So numerator will be our function u, and the denominator will be our function v. So ux equals to 4x squared plus 5x plus 8. That means u prime x will become 8x plus 5. And that's define our vx, which is the denominator 2x, and v prime x will be 2. So let's use the definition of the quotient rule. So we know f prime x equals to u prime v minus u v prime over v squared. So we can write f prime x equals to 8x plus 5 times by the v, 2x, minus u, which is 4x squared plus 5x plus 8 times by v prime, which is 2, divided by v squared, which means 2x whole thing squared. And that's simplify the numerator. We're going to have 16x squared plus 10x minus 8x squared minus 10x minus 16 over 4x squared. And collect the like terms. You're going to have 8x squared minus 16 divided by 4x squared. And that's divided into two terms, so we can compare the answers from the power rule. So we get 8x squared divided by 4x squared minus 16 over 4x squared. We're going to have reduce the fraction, and we're going to have 2 minus 4 over x squared. As you can see, they are the same answer. Next, we're going to use product rule to do this. So in order to use product rule, we have to write f as a product. That means we have to bring up the denominator. And once again, we have to define our u and v. So our ux will be the first bracket, which is 4x squared plus 5x plus 8. So u prime will be 8x plus 5. And our vx will be 2x whole thing to the exponent negative 1. Then v prime x will be negative 1 bring it down, 2x to the exponent negative 2 times by differentiation of the base, which is 2. And then we're going to use the definition of the product rule, which is u prime v plus uv prime to differentiate it. So f prime x will be u prime 8x plus 5 times by v, 2x to the exponent negative 1, plus u, 4x squared plus 5x plus 8 times by v prime, which is negative 2 times by 2x to the exponent negative 2. And now we have to common factor them. So I have to say f prime x equals to 2x to the exponent negative 2. That's what they have in common. What's left in the bracket? 8x plus 5 times by 2x. And plus 4x squared plus 5x plus 8 times by negative 2. And close bracket. And that simplify the square bracket. So expand all the terms. So you get 16x squared plus 10x minus 8x squared minus 10x minus 16. And you're going to have 2x holding negative 2. You have 8x squared minus 16. And since the 2x has an exponent of negative 2, that means we have to bring them into the denominator. So we get 8x squared minus 16, which is on the numerator, over 2x holding square, which is 8x squared minus 16 divided by 4x squared. And that's divided into two terms again. 8x squared divided by 4x squared minus 16 divided by 4x squared. That's reduce the fraction. And that's right, our final answer, 2 minus 4 over x squared, which is the same answer as the other two. As you can see from here, the power rule will be the easiest one to use. Therefore, whenever you have a fraction, and if there's only one term in the denominator, I will highly recommend you divide them into individual terms and then use power rule to differentiate. For example number 2, since there are two terms in the denominator, that means we can use power rule to differentiate this function. So we either need to use the quotient rule or we are going to use the product rule. Now let's try to use the quotient rule first. So let's define our function u and v. So u will be the numerator, 3x minus 4. So u prime will be 3. And v is 2x minus 5. That means v prime will be 2. So using the quotient rule, we know f prime will be u prime v minus u v prime divided by v squared. So we're going to have 3 times by v minus u times by v prime over v squared, which is 2x minus 5 whole thing squared. And let's expand the numerator. We get 6x minus 15 minus 6x plus 8 over 2x minus 5 whole thing squared. So we're going to have negative 7 over 2x minus 5 whole thing squared. And we put the negative sign out, so 7 over 2x minus 5 whole thing squared. That's the differentiation for f prime. Next, let's use product rule to differentiate this function. So first, let's rewrite f into a product. So bring up the denominator using exponent -1, and let's define our u and v. So our function u will be the first bracket. So u prime, once again, will be 3, but v prime will be different now because v is 2x minus 5 to the exponent -1. Then v prime will be negative 2x minus 5 to the power -2 times by 2. So now let's use the product rule. So f prime equals to u prime v plus u v prime. That's substitute in. So u prime is 3, v 2x minus 5 to the exponent -1 plus u 3x minus 4 v prime, which is negative 2x minus 5 to the exponent -2 times by 2. And negative means -1. And then let's look at what do they have in common. They have 2x minus 5 in common, but between -1 and -2, -2 is a small exponent, so we're going to factor out 2x minus 5 to the exponent -2. And what's left on the first term now? So we have a 3, 2x minus 5, minus 2 times by 3x minus 4. I combine the -1 and 2, so it becomes -2. And that's simplify the square bracket by expanding it. So 6x minus 15 minus 6x plus 8. So we're going to have 2x minus 5 to the exponent -2 times by -7. And let's put the negative exponent in the denominator. So we're going to have -7 over 2x minus 5 whole thing squared. In this example, power rule cannot be used because there is more than one term in the denominator, but between the quotient rule and the product rule, quotient rule is easier to use in this case. The reason is there's no other exponents. So if the function doesn't have anything like whole thing to the exponent 2 or whole thing to the exponent 3, then quotient rule will be the rule that we're going to use. For example number 3, as you can see, once again, there are two terms in the denominator. That means power rule cannot be used. So now that's differentiated with the quotient rule. Let's define our function u, which is the numerator. Let's define our function u and v. So u is the numerator, which is 3x minus 4 to the exponent 4. And let's find the differentiation. Bring down the exponent 4. 3x minus 4 to the exponent 4 minus 1 is 3 times by differentiation base, which is 3. And we do vx, which is the denominator, 2x minus 5 to the exponent 3. So v prime will be bring down the exponent 3, 2x minus 5 to the exponent 3 minus 1 is 2, times by differentiation of the base, which is 2. Using the quotient rule, f prime x will be u prime v minus u v prime over v squared. We can write u prime 4 times 3x minus 4 to the exponent 3 times by 3 times by v 2x minus 5 to the exponent 3 minus u, which is 3x minus 4 to the exponent 4 times by v prime 3 times 2x minus 5 squared times by 2 over v squared, which is 2x minus 5 to the exponent 3 whole thing squared. Next, we have to simplify it by common factor it. So look at the numerator. There is a 3 they have in common. So we're going to factor out the 3, and this one's out. Next, we're going to common factor out the 2, because there's a 2, there's a 4. So we can common factor out the 2. So this is out, that one's out, so it becomes a 2. Next, they have 3x minus 4 in common, but this exponent 3, that's exponent 4. So we take our smaller one, so 3x minus 4 to the exponent 3. So this becomes nothing now, and there's only one left. And they have 2x minus 5 in common. There are 3 of them here, there are 2 of them here, so we can factor out 2 of them. So this is out, this becomes 1 left. So what's left? We write down 2x minus 5 minus 3x minus 4, close bracket, over 2x minus 5 to the exponent 6. Now, let's simplify it further. You can write 6, 3x minus 4 to the exponent 3, and they have 2x minus 5 in common, so this becomes 4, and we're going to write down what's inside the square bracket here. So 4x minus 10 minus 3x plus 4 and close bracket. And we are going to combine like like terms in the square bracket, which is x minus 6 over 2x minus 5 to the exponent 4. So that will be our final answer. 3x minus 4 to the power 3, x minus 6 divided by 2x minus 5 to the exponent 4. Next, we're going to try to use the product rule. So once again, we have to rewrite the function first into a product. So fx equals to 3x minus 4 to the exponent 4, and bring up the denominator will become exponent negative 3. Define our ux, which is the first bracket, 3x minus 4 to the exponent 4, and let's find the differentiation, which is 3x minus 4 to the exponent 3 times by differentiation of the base, which is 3. And vx is the second bracket, 2x minus 5 to the exponent negative 3. So v prime x will be, bring down the exponent, negative 3, 2x minus 5 to the exponent negative 4 times by the differentiation 2. Then let's try to use the product rule. So f prime will be u prime v plus u v prime. So it's going to be 4 times 3x minus 4 to the exponent 3 times by 3 times by the v, 2x minus 5 to the exponent negative 3, plus u, which is 3x minus 4 to the exponent 4 times by v prime. So it's going to be negative 3, 2x minus 5 to the power negative 4 times by 2. Next, we're going to common factor to simplify the expression. So they have a 2 in common. So we factor out a 2. This will become a 2. This will become a 1. They also have a 3 in common. So we factor out the 3. So this will become a 1. This will become a negative 1. And we are going to have a 3x minus 4 in common. So this is exponent 3, this is exponent 4. So we're going to factor out exponent 3. So I have 3x minus 4 to the exponent 3. So this is gone. This will have 1 left. And we also have 2x minus 5 in common. This is negative 3, this is negative 4. Negative 4 is smaller, so we factor out negative 4. So this is gone. This will become 1 left. And then we fill in the rest in the square bracket. So 2 times 2x minus 5 plus 3x minus 4 times by negative 1. So first, we are going to rewrite the function into individual terms. Square root is x to the exponent 1 over 2, which is 2x divided by x to the power half minus 8 over x to the power half. And power divided by a power you do subtraction between the exponents and bring the x up, the exponent becomes negative. So you have 2x to the power half minus 8 multiplied by negative half, x to the exponent negative 3 over 2. Then you're going to have 2x to the power half plus 4x to the power negative 3 over 2. Next, simplify the square bracket. By expanding and collect the like terms. And move the negative exponent into the denominator. And here is our differentiation. So whenever you have a function that's a fraction that also have an exponent, then we will recommend you to use the product rule because that will be easier to do it. So for example 4, we are finding the coordinates on the function f where the tangent line is a horizontal line. That means slope of a tangent is going to be 0. Let's look at the function f. It's a fraction and there is only one term in the denominator. That means we could use the power rule to differentiate, but first we have to divide them into individual terms. So square root of x can be written as x to the exponent half, and we're going to put them into two terms. And a power divided by a power, you subtract the exponents. And bring up the denominator, the exponent becomes negative. After this, we can do the differentiation. F prime will be 2 times half x to the exponent negative half plus a times negative half x to the exponent negative 3 over 2. And simplify them. Common factor them. Now we are ready to find the point. So we let f prime, which is the slope, equals to 0 to find x. So 0 equals to x, negative 3 over 2, x minus 4. This implies negative 3 over 2 equals to 0, or x minus 4 equals 0. And negative exponent really means 1 over x to the exponent 3 over 2 equals 0. That means 1 equals 0, which is invalid. And x minus 4 equals 0 implies x equals to 4. And once we get the x values, we can substitute into the f to find the y values. So y equals ff4 equals 2 times by 4 plus 8 over square root of 4, which is 8 plus a over 2, which is 8. Therefore, the point on the fx that the tangent horizontal line is at 4 and 8. Exemplify an initial population P of 1,000 bacteria grows in number according to the equation given here. Where T is in hours, we want to find the rate, which means we want to find the slope, which means we want to find P prime, at which the population is growing at 2 hours. That means you want to find P prime at T equals to 2. First, let's find P prime. 1,000 is coefficient, so leave them outside. So we're going to differentiate inside the bracket. Differentiation 1 is a constant, so it's going to be 0. And the next term is a fraction, so we're going to use quotient rule. So denominator square. Differential numerator is 4 times by the denominator minus the numerator times by differentiation of the denominator, which is 2t. Next, let's simplify the square bracket. by expanding and collecting the like terms in the numerator. And now we are ready to find the rate of change when t equals to 2. So p prime at 2 equals 1,000 times by negative 4 times by 4 plus 200 divided by 4 plus 50 whole thing squared. This equals to 1,000. And if you reduce the fraction, you're going to have 49 over 729. So our answer will be 49,000 over 729, which is approximately 67.22. Since we are talking about number of bacteria, so we will round off. Therefore, we say the bacteria is growing at a rate of 67 per hour.